All right. Let's continue and move over to question number two. Okay. Then question number two says how many electrons must be removed from a neutral object to leave a net charge of what 0.5 microcoulombs. All right, for this particular question, okay, you see the same formula we are going to use. We're going to use the same formula, number one. And also, if you are solving, please try to consider some words, some changes, because you know, simplicity is all about what? Conversion. Yes, always respect the unit of a particular things you are looking for or the things that is given. Okay. Now, from the question, you can now know that the same formula, which is Q equals NA. Okay, Q equals NA. I will draw my line again. Then from the question given, Q is given. Okay, please pay attention to this. Q is given as 0.5 microcoulombs. Okay, and remember this thing can be converted because you cannot solve with this. You're going to multiply this by converting direct to coulomb. You're going to multiply by 0.5 times 10 raised to power minus 6 coulombs. Take note of this. Now and again, n is what we are looking for. Okay, we are looking for what? N. Then E, which is what? Charge of electron and proton, is always 1.6 times 10 raised to power minus 19. Remember, sometimes this thing is what? Plus or minus. But in case where you use plus or minus, please look on your screen so that you know the possible case where you are going to use what? Positive and what? Negative. So just look on your screen for more what? Understanding on that. All right. Now again, from the question given to us, we can now say that we have since we are looking for n, which is the total number of proton and electron, therefore we are going to make this n the subject of the formula. We're going to make this n the subject of the formula in the sense that we are going to divide both sides by the coefficient of n, and coefficient of n is e. So here will be e, here will be what? E. Therefore, e will cancel e on this side. Coming to this side, we now say that n equals q, which is the charge, all over e. All right. Therefore, n equals, from here we now have 0.5 times 10 raised to power minus 6 all over what we have for here. That should be 1.6 times 10 raised to power minus 19. Remember the constant. So once you point this in your calculator, you don't need to waste much of your time. Please, there's a trick that guides it. In case if you need the trick, I can help you on that. So that's why in CBT exam is all about trick. Okay, like me, I don't have to waste any money. In fact, I don't waste time here. I know what I can do. So try in one or two places I get my answer. That's why I normally say that for you not to crack your brain, make use of your calculator. But for me, I have the trick. If you need the trick, and as well chat me up, I will show you how to do it. So your point should be that should be what? 3.125. Okay, 3.125 is final answer for this second question number 2 times 10 raised to power 12. All right, this is the final answer. Is this supposed to have unit? No. Reason because, please, if you still remember that, look at what you are dealing for. The number of what proton and the neutron has no unit, in the sense that the unit of charge is what? Coulombs, and that of what? Electron is also what? Measured in coulomb, because all of them are talking about charges. So for it to calculate the total number of charges, then coulombs will cancel coulombs. Therefore, total number of charges is a what? In fact, has no what? Unit. Okay, so this is the final answer to this second question. All right, this is question number 2, and this is question number 1. Okay, question number 1, and as you can see, it is well explained and well expressed. The solution is clear. All right, if you need more of this, yes, you can chat me up for more the text under this, especially if you need more expression under quantization of what charges. All right, I remain your friend's blood, always ready to give you the best. I love you. Bye bye.